फिर नेक्स्ट न्यूमेरिकल स्टार्ट करते हैं, वो है वन वे स्लैब डिजाइन। वन वे स्लैब डिजाइन और कैंटिलीवर स्लैब डिजाइन में स्टेप सेम रहेगा, बट यहां पर आपको डिटेल्स ऐसा देके आपको कंफ्यूज करेंगे, ज्यादा दे देंगे आपको। 3.5 मीटर्स बाय 7.8 मीटर्स का पैनल साइज है। वन वे स्लैब फॉर अ रूम विद क्लियर इनर साइज ऑफ 3.5 meters by 7.8 meters. Slab is supported by beams width of 230 mm along all the edges. The slab is subjected to floor finish दिया है, live load दिया है, use concrete grade of M20 and FE 500 reinforcement. Draw the reinforcement details. Similarly, same type of numerical for a passage measuring 3.2 meters by 7.5 meters with 230 mm wide beams around all the edges. Design the suitable slab using live load 3 kilonewton per meter square, floor finish M25 and 500 grade. Assume moderate exposure condition. Show details of the reinforcement. Okay. So now, see one way slab design में we will अभी मॉडरेट एक्सपोजर कंडीशन इट इज गिवन, मॉडरेट एक्सपोजर कंडीशन दिया है, मतलब इससे कंफ्यूजन क्रिएट करने के लिए कि व्हाट टू डू। सो व्हेन सच काइंड ऑफ कंडीशंस आर गिवन, व्हेन M25 grade is not given, so we will be taking for moderate exposure condition minimum grade of concrete will be M25. Remember, now Ly by Lx ratio, first step is always to determine whether it is one way slab or two way slab. So Ly is 7.8 and Lx is 3.5. 7.8 by 3.5 value is 2.23, which is greater than 2 meter 2. So torsion Ly by Lx is greater than 2. The slab shall be designed as spanning one way. So therefore design as one way slab. Okay, now next step is design it as one way slab. Depth of the slab for a simply supported slab condition. So deflection criteria is Ly by Lx, L by D ratio is 20. So that will be L by D ratio equal to 20. So slab panel is given as 7.8 and 3.5. The smallest slab dimension will be taking, that is 3500. 3500 divided by 20 equal to D. So this value is 3500 divided by 20. So this is 175 mm. Okay, now take capital D equal to 175 plus 25. This is cover. So this is 200 mm depth and effective depth D equal to 175 mm. Okay, so this part is understood. Now next will be the load calculation. Load calculation के लिए, that is bending moment and shear force के लिए required रहेगा. So dead load of the slab is, where dead load is 0.25 into 1 into 25. So ये value 0.25 into 25, it is 6.25 kilonewton per meter. So live load is again 3 kilonewton per meter. Floor finishes, this is, we'll write it like this, 3 kilonewton per meter square into 1, that is 3 kilonewton per meter. Floor finish is given as 1.5 kilonewton per meter square into 1, that is equal to 1.5 kilonewton per meter. So total value is 6.25 plus 3 plus 1.5. This is 10.75 kilonewton per meter. This is equal to W. So W आ गया आपको 10.75. Ultimate load WU equal to 1.5 into 10.75 you have to do. So it is 1.7. This is equal to 16.13. Sorry, 1 minute. See, depth of the slab is 0.20 into 1 into 25. So this is equal to 5 kilonewton per meter. So this is 3. This is 9.5 kilonewton per meter. So this is 9.5 kilonewton per meter. So this will be 1.5 into 9.5. So total is 1.5 into 9.5. This is 14.25 kilonewton per meter. लोड आ गया स्लैब के ऊपर, दैट इज 14.25 किलोन्यूटन पर मीटर. इस लोड को यू नीड टू कैलकुलेट. नेक्स्ट स्टेप इज इफेक्टिव लेंथ. अभी WL²/8 जो फॉर्मूला है बेंडिंग मोमेंट का, दैट इज करस्पॉन्डिंग टू इफेक्टिव लेंथ. सो इफेक्टिव लेंथ, one inner to inner dimension is 3500 and width of the column is width of the wall is 250. So effective length is least of 3.5 plus 0.2523 plus 0.23 or 230, 0.23 plus by 2, 0.23 by 2, and another condition is 3.5 plus depth, that is depth, that is 175, effective depth 175 plus 0.175 by 2 plus 0.175 by 2 effective depth. So this value is 3.5 plus 0.23, it is 3.73 meter, and another one is 3.5 plus 0.175, so this is 3.68 meters. So effective length L effective equal to least is 3.68 meters. So mu limit, mu you have to calculate. Mu formula is WL²/8. W value is W is 14.25 into L effective length is 3.675 square divided by 8. So ये वैल्यू आता है 14.25 into 3.675 square divided by 8. ये आता है आपको 24.06 kilonewton meter. Okay. Next you have to calculate shear force. Shear force is again WUL by 2. 14.25 into 3.675 divided by 2. So this is 14.25 into 3.675 divided by 2. This is 26.18 kilonewton. Okay. Now iska abhi you require to find out maximum limit. Maximum limit is given by this equation. On simplifying, XU max by D जो रेशियो है 0.46 for 500 डालने के बाद, क्योंकि ग्रेड ऑफ स्टील हियर इज 500. पेज नंबर 96 क्लॉज नंबर G1.1.C में दिया है. When you substitute and simplify this equation, आपको इक्वेशन आएगा mu limit equal to 0.133 FCK BD square. Okay, this is for BD square. This is for FA 500. So ये वैल्यू हो जाता है आपको 0.133. FCK is 20, yes 20, into B value is 1000 into D value is 175 square. So this is divided by 10⁶ to make it into kilonewton meter. 0.133 into 20 into 1000 into 175 square divided by 10⁶. आपको आएगा ये वैल्यू 81.46 किलो न्यूटन. सो MU limit is greater than MU. Therefore, design singly reinforced and the depth adopted is adequate. Okay. Now next, अभी depth safe हो गया, singly depth safe हो गया हमारा. So now next will be calculation of AST. AST calculation के लिए formula AST equal to 0.5 FCK BD divided by FY into 1 minus bracket of square root of 1 minus 4.6 MU divided by BD square FCK. So इस equation में आपको substitute करना है. 0.5 into FCK is 20 into 1000 into D value is 175 divided by FY is 500 whole in 1 minus square root of 1 minus 4.6 into 24.05 into 10 raised to 6 divided by B value is 1000 into D value is 175 into FCK is again 20. This is square. इसको सॉल्व करिए आप. जब आप सॉल्व करेंगे आपको AST आएगा. So AST value is 331.81. 331.81 mm square. This is AST required. Required AST is so much 331. Now you have to calculate the minimum AST. Check करने के लिए whether the required AST is greater than the minimum AST. When the required AST is less than the minimum required AST, then you will be providing minimum AST. So AST minimum for HYSD bar is 0.12% of BD. You know this one. 0.12 divided by 100 into B value is 1000 into D value is 175. So on solving this, you will be getting 210 mm square. Okay. So AST minimum. AST required is greater than AST minimum. So now you will be calculating the number of the spacing of the bar. So main reinforcement spacing calculation using 10 mm bars will provide 10 mm bars. You can provide 8, any as per your requirement. Make sure that the reinforcement which you are providing has a spacing in the range of 150 to 200. So AST of 1 bar equal to pi by 4 into D value is 10 square divided by area required is 331.81 into 1000. So this is 236.70 mm. So this will be, therefore, provide 10 mm dia at 200 mm center to center. Now we have provided 200 mm center to center for main reinforcement. Now you will be calculating distribution reinforcement. So distribution reinforcement AST के लिए we will take AST minimum for distribution steel. AST equal to AST minimum, that is equal to 210 mm square. So this one यहाँ पर SV equals to pi by 4 into 8 square divided by 210 into 100 नहीं, ये 1000 है. So this value आपको मिलेगा again 228 mm. So therefore provide 8 mm dia at 200 mm center to center. So AST minimum भी हो गया, AST, that is AST main reinforcement also is done, and AST of distribution steel is also done. Now you have to calculate whether the spacing that जो 200 हम provide कर रहे हैं, which is greater than the minimum spacing. So check for maximum spacing. So for slab is the horizontal distance between the parallel main reinforcement bar shall not be more than 3 times of the effective depth of solid slab or 300 mm, whichever is smaller. So one condition says that it is not shall not be more than 3 times of effective depth of solid slab, effective depth, and another is 300. So 3 into effective depth is 175. So this value will be 525 mm, or another is 300. So horizontal distance between reinforcement shall not be more than 300 mm or this value, whichever is smaller. So AST provided is sufficient. Matlab the spacing provided is within these two limits. Okay, within these two values, that is 200 is sufficient. Now next is check for shear. So check for shear में आपको shear check करना है. Tau v equal to vu is vu is 26.1. vu divided by b into d. vu is 26.184 into 1000 divided by b value is per meter length, that is 1000 into 175. So 26.184 into 1000 divided by 1000 into 175. So this value is 0.15 Newton per mm square. आपको tau v आया, nominal shear. So now you have to calculate the tau c value. So tau c is given on page number 73. So tau c is given on page number 73. This is page 73. Tau c you have to calculate it. For that 100 AS by BD percentage of steel you have to calculate. So that is percentage PT of steel equal to 100 into AS divided by B into D. So 100 into AS is pi by 4 into 10 square, that is B value is 1000 into D value is 175. So this is 100 into 1 minute. See, this is 100 into AS divided by BD it is, no? So it is 100 into AS value is 331 divided by B value is 1000 into D value is 175. So you will be getting percentage of steel 100 into 331 divided by 1000 into 175. So this is 0.19%. So 0.19% is lying between 0.15 and 0.25, and M20 is 0.28 and 0.36. In दोनों के बीच में the value is there. So you have to calculate for 0.19% कितना होता है हमको tau c value. So this is 0.15, this is 0.19. So sorry, this is 0.19 0.25 we require for 0.19. So this is 0.28 और ये है 0.36. So यहाँ पर हमको टाउ सी कैलकुलेट करना है. ओके, टाउ सी कैलकुलेट करना है. So इसको आप लिख सकते हैं, ऐसा 0.25 माइनस 0.19 डिवाइडेड बाय 0.25 माइनस 0.15 इक्वल टू 0.36 माइनस टाउ सी डिवाइडेड बाय 0.36 माइनस 0.28. इंटरपोलेट करिए आप, टाउ सी का वैल्यू आ जाएगा आपको. सो इट इज 0.25 माइनस 0.19 इंटू 0.36 माइनस 0.28 divided by 0.25 minus 0.15. So 0.36 minus answer, it is 0.31. So we got tau c as 0.31 but tau v हमको आया था 0.15. Okay, so tau c is greater than tau v, therefore safe. Okay, shear check is done. Next हमको करना है deflection check. ये सभी checks if in question it is given आप solve करिए, नहीं दिया है तो आप marks के according देख सकते हैं आप इसको. So percentage of steel we got it as 0.19%. So FS value is so much. So this one will be 0.58 into 500. Area required is 331 and area provided 1 bar, that is 10 mm diameter we have provided, that is 10 into 5 by 4 into 10 square into 1000 divided by spacing is 200 mm. So this value आएगा आपको 5 by 4 into 10 square into 1000 divided by 200. So this आपको आ गया 329.70 mm square. आप इसमें सब्स्टिट्यूट करिए आप 392.70 and you solve FS. FS equal to 0.58 into 500 into 331 divided by 392.70. So you are getting FS value is 244.44 Newton per mm square. So इस FS value के लिए आपको table number 4 से रेफर करके you have to calculate, evaluate FC modifying factor F1 value. See, FS value is 215 यहाँ पर कहीं पे, and steel percentage we got it as 1.19, that is 0.2. So when you interpolate that आपको आएगा percentage modification as somewhere 1.8 value. So you take it as 1.8 F1. So F1 is 1.8, F2 is 1. L by D maximum and L by D provided. Maximum is L by D basic into F1 into F2 into F3. So L by D basic value is 20 into F1 is 1.8 into 1 into 1. Okay, so L by D provided is 3500 divided by depth is 175. So this value is 3500 divided by 175. आपको आ रहा है 20. So this one आपको आएगा 20 into 1.8. So this is 36. So L by D maximum is greater than L by D provided. Therefore deflection under control. Last part is sketch of detailing, that is reinforcement details. See, reinforcement details में the ये रहेगा आपका 3500 mm. So wall thickness is 230 mm. So wall thickness is 230 mm. Okay, the main reinforcement is 10 mm at 10 mm bar at 200 mm center to center, main reinforcement. Okay, so similarly ये हो जाएगा अपना main reinforcement, that is 10 mm dia at 200 mm center to center, and this dot are distributory bars. So this is 8 mm dia at 200 mm center to center, and this is also same 8 mm dia at 200 mm center to center. Okay, इतना हो गया. द reinforcement पार्ट सब कुछ हो गया आपका ये डिजाइन ऑफ वन वे स्लैब का. लास्ट पार्ट दैट इज डिजाइन ऑफ टू वे स्लैब. टू वे स्लैब लास्ट पार्ट है आपका. डिजाइन ऑफ सिंपली सपोर्टेड टू वे स्लैब. 3 टाइप्स ऑफ न्यूमेरिकल आया 2 पेपर्स में, दैट इज मार्च 2024 और फरवरी 2023 में. यहां पर डिजाइन neglect distribution and steel check, neglect distribution torsion reinforcement check for shear, neglect design of distribution and check for shear बोलकर दिया है specifically. So no need to calculate shear check, distribution check and all. Okay, so A part भी same रहेगा जैसा आपने किया था for one way slab and cantilever. That is first step will be determining whether it is one way slab or two way slab, और उसके बाद डिटेल्स लिखने जाना है बीम विड्थ, लाइव लोड, फ्लोर लोड. बट फॉर दिस वी विल बी टेकिंग वन स्पेशल टाइप ऑफ न्यूमेरिकल wherein it is given two adjacent edges are discontinuous. Okay, such kind of slab को डिजाइन करेंगे. स्लैब इज सपोर्टेड ऑन beam of 230 mm width around all the edges. Live load is 2.5 kilonewton per meter square and floor load is 1.0 kilonewton per meter square. M20 grade दिया है, Fe 500 steel दिया है. Show the details of reinforcement with neat and clean sketch. Design the distribution steel torsion reinforcement and check for shear. You neglect these things. So the given depth, given data, effective spans Lx is 3.23 mm meters and Ly is 4.73 meters. Width of beam is 230 mm. Live load is given as 3.0 kilonewton per meter square and sorry, not 3 point, it is 2.5 kilonewton per meter square and floor load is given as 1 kilonewton per meter square. So Now material property is given as M30. So this is FCK equal to 30 Newton per mm square, and Fy and Fe 500 is given, that is Fy equal to 500 Newton per mm square. Okay. So all the grades we have written. So this is 30, two adjacent ends are discontinuous. Cover we will take it here as 20 mm. Okay. So next step is load calculation. For load calculation, here we will assume the slab thickness of 150 mm. So load calculation is 0.15 into 25. Live load is 22.5, and this is 1.0. Live load is, floor load is 1.0. So this one is 3.75 kilonewton meter. So this is 2.5 kilonewton meter. So this is also 1.0 kilonewton per meter. So this one is 7.25 kilonewton per meter. This is W. Okay, next we have to calculate WU, that is ultimate load. So that is ultimate load equal to WU equal to 1.5 into 7.25. So this one value will be coming as 1.5 into 7.25. So this is 10.88 kilonewton per meter. So now next part is calculation of bending moment. Load मिल गया, effective lengths are given, Lx and Ly. So the next step is calculation of bending moments. That bending moment is given on page number 90 for two-way slab as Mx and My. Two moments will be coming. There will be no distribution bars here. There will be main reinforcement on both sides. So that is Mx is alpha x and alpha y, that is WLX square and WLY square. Okay. So now Ly by Lx ratio we will be doing. That is again Ly is 4.73 divided by 3.23. So this is 1.464, which is less than 2. Therefore design as two-way slab. Design as two-way slab. So you have to calculate alpha values, means alpha and alpha x and alpha y. There are two coefficients that will be multiplied to calculate mx and my. So that is given on page number 91, table number 26. So on this table, table number 26, we will be calculating alpha x, that is short span moment, and alpha y, long span moment. Our condition is two edges discontinuous. negative moment at continuous edge and positive moment at bit span. Like this, they will be having two adjacent edges discontinuous. So our coefficient, that value is 1.4 and 1.5. So hamara value is lying between these two, that is these two values. So Ly by Lx ratio, we got it as 1.464. So Ly by Lx, we got it as 1.464, that is lying between 1.4 and 1.5. And for discontinuous, two edges are discontinuous, so ये दो conditions आएंगे आपको. So इन दोनों के बीच में you have to calculate. First step is negative coefficient along short span. Negative coefficient along short span equal to, it is between these two factors. So जो values है values are 1.4 and 1.5. So ये value रहेगा आपका 0.071 and ये value रहेगा 0.075. So it is between in these two, that is 1.464. Correct. So यहाँ पर हमको this value negative factor भी required, that interpolate करके we can evaluate 1 minus 1.4 divided by 1.5 minus 1.464. Sorry, 1 minute. 1.5 minus 1.464 divided by 1.5 minus 1.4 equal to 0.075 minus unknown divided by 0.075 minus 0.071. So ये factor आपको आएगा on calculation. Negative moment is 0.073. Okay, so this is alpha x negative. So alpha x positive भी रहेगा आपको, because positive moment is there, these two factors. So positive coefficient along short span. So this one again you have to calculate similar way. 1.4 and 1.5, ये आएगा आपको 0.053 and 0.056. 1.464. Okay, so again you interpolate 1.5 minus 1.464 divided by 1.5 minus 1.4 equal to 0.056 minus unknown divided by 0.056 minus 0.053. So on solving this one, alpha x positive आपको आएगा So when you solve this one, आपको आएगा 1.5 minus 1.464 divided by 1.5 minus 1.4 into 0.056 minus 0.053 . So ये आपको almost this value is coming 0.056 only. Okay, now next is long span moment, that is 0.047 and 0.035. Negative long span coefficient, positive long span coefficient equal to. So those values are 0.047 and 0.035. This is 0.047 and 0.035. Okay. So now negative moment long span पे आया 0.047, positive moment 0.035, alpha y negative and alpha y positive, lx हमारा 3.23 है and ly is 4.73, alpha x is 0.073 and alpha y is 0.056. Now we have to calculate the corresponding values. See now mx negative equal to, so that is alpha x negative into wu into lx square. Wu value is 10.88, so this will be how much? 0.073 into 10.88 into 3.23 square. So this is the negative moment, and mx positive equal to alpha x positive into wu into lx square. So this is alpha x is positive is 0.056 into wu is 10.88 into 3.23. Okay. So again my negative equal to alpha y negative into wu into ly square. So this value is 0.047 into 10.88 into ly is 4.73 square. So this is my positive equal to alpha y positive into wu into ly square. So this is 0.035 into 10.88 into 3 point, sorry, into 4.73 स्क्वायर. अभी आप इसको कैलकुलेट करेंगे तो आपको मोमेंट्स आएंगे इस चीज फुल ऑल ऑन द स्लैब. 0.073 into 10.88 into 3.23 square. So you are getting this negative moment as 8.29 kilonewton meter. So this is mx negative. So my negative is 0.047 into 10.88 into 4.73 square. So you are getting my negative as 11.44 kilonewton meter. So mx positive is 0.056 into 10.88 into 3.23 square. So this you are getting it as 6.36 kilonewton meter. So 0.035 into 10.88 into 4.73 square. So this you are getting it as 8.52 kilonewton meter. अभी आपको 4 मोमेंट्स आ गए. अभी now you have to select 2 moments, that is maximum of positive moments and maximum of negative moments for load for AST calculations. Okay, so maximum of positive moments are 8.52, that is my positive. Maximum of negative moments is my negative is 11.44. 11.44, My negative is 11.44 kilonewton meter, and My positive is 8.52. सो इतना मोमेंट आ गया. सो ये है so material is Fe500 and M30. Okay, now we have to calculate mu limit to check whether the depth assumed is correct. Mu limit is 0.133 into FCK into B into D square for Fa 500 steel. So mu limit 0.133 into 30 into D value is 1000 into D value is 150 square divided by 1 minute. This one will be 130 square because capital D equal to 150 mm, cover is 20, small d equal to 130 mm, cover equal to 20 mm. So this is 10 raised to 6. So you will be calculating the value 0.133 into 30 into 1000 into 130 square divided by 10 raised to 6. So you are getting maximum moment as 67.43 kilonewton meter mu limit. So which is greater than mu, whatever all the values. So therefore depth assumed is safe. So now you have to calculate the moments, that is for these two values. One is short span and long span moments. See, Mx negative is 8.29, Mx negative is 8.29 kilonewton meter, and Mx positive equal to Mx positive is 6.36 kilonewton. इन चार मोमेंट्स में से you have to calculate My में मैक्सिमम, Mx में मैक्सिमम. So My में मैक्सिमम is 11.44. So we'll separate these two. My equal to 11.44 kilonewton meter and Mx equal to 8.29 kilonewton meter. So इन दोनों में से आपको AST कैलकुलेट करना है. AST equal to 0.5 FCK BD divided by Fy into 1 minus square root of 1 minus 4.6 mu divided by BD square FCK. So this one is again same, AST equal to 0.5 FCK BD divided by Fy into 1 minus square root of 1 minus 4.6 mu divided by B into D square into FCK. Okay, so now AST इसको substitute करो. 0.5 into FCK value is 30 into B value is 1000 into D value is 130 divided by 500 into 1 minus square root of 1 minus 4.6 into 11.44 into 10 raised to 6 divided by B value is 1000 into D value is 130 square into 30. So ये value होगा 4.6 into 11.44 into 10 raised to 6 divided by 1000 into 130 square into 30. 1 minus answer. .5 into 30 into ये आया 207.94 mm square. So this is AST, one AST, and another AST is 0.5 into 30 into B value is 1000 into D value is 130 divided by 500 into 1 minus square root of 1 minus 4.6 into mu value is 8.29 into 10 raised to 6 divided by B value is 1000 into 130 into 30. 4.6 into 8.29 into 10 raised to 6 divided by 1000 into 130 into 30. mm square. So AST minimum calculate करना है. Minimum AST is 0.12% BD. So this is 0.12 divided by 100 into B value is 10 raised to 3 into D value is 130, 150. So this is 0.12 into 1000 into 150 divided by 100. So minimum AST is 180 mm square. So MX may, that is the shorter span moment, will be providing AST minimum, and on the longer span will provide 207 mm square, because ये देखिए यहाँ पर AST minimum is more than the required AST, so we will calculate spacing. Spacing हो गया last part, that is spacing calculation. Short span reinforcement equal to using 10 mm dia bar, SV equal to pi by 4 into 10 square into 1000 divided by 180. So this is pi by 4 into 10 square into 1000 divided by 180. Instead of, we'll take it at 8 mm diameters. So this is 180, आपको आएगा 279.25 mm. Therefore provide 8 mm dia at 200 mm center to center and long span reinforcement, again using 8 mm dia bars, SV equal to pi by 4 into 8 square into 1000 divided by 207.94. Pi by 4 into 8 square into 1000 divided by 207.94. This is 241.73 mm. Therefore, provide 8 mm dia at 200 mm center to center. Now the reinforcement detailings, both side में same reinforcement आएगा आपको. So these all are same. 8 mm dia at 200 mm center to center. This is also same. 8 mm dia at 200 mm center to center. So slab का part हो गया. All three types of slabs are done. That is cantilever, one-way slab and two-way slab. We'll wind it up here.